Hi everyone, welcome to Mrs. Shin's class. Today we're going to learn how to estimate the area under the curve. Remember last time when we were learning integration, we learned how to find the area under the curve, right? This time we're going to continue doing so. However, sometimes it's hard to find the area under the curve because it's not able to integrate the function given. So in that case, we approximate the area under the curve by three different methods. The first one will be rectangle rule that we're going to cover today. Another one will be Simpson's rule and trapezium rule. Okay, so today we're going to cover rectangle rule and see how we can estimate the area under the curve. Okay, so let's have a look at this question. Rectangle rule. Find the area under the graph of a function. This is the equation. Okay, between x is 0 to 3 using 6 sub-intervals. Okay, 6 sub-interval is very important. Start and the end point is important. Okay, so let's see how this rule is used. Right, so we have the function from e to the power of x from 0 to 3. We're going to divide this into 6 sub-intervals. Okay, so let's have a look at this one. The rule for width is end minus the start divided by sub-interval. What it means, end minus the start, that's going to give me the width. And if I divide it by 6, the sub-interval 6, okay, it's going to give me the width of each rectangle. Okay, so let's have a go. The width is equal to end is 3 minus the start is 0, and we would like to divide it into 6 sub-intervals. So basically it's 3 over 6, which is 0.5. Good. That means each width of the rectangle is 0.5. So I need to divide it, boom, 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 like this. And I can fill out the numbers in between. Okay, for this rectangular rule, the most important thing is seeing what is the midpoint. Okay, so I know that one rectangular box is from 0 to 0.5. So the middle one, okay, the midpoint of this would be 0.25. Okay, so another second rectangular box is from 0 to 5 to 0.5 to 1. So midpoint in between that will be, right, it's adding on another 0.25, so that value will be, okay, another rectangular box, midpoint, 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 adding 0.25 from 1, 1.5, 2, 2.5, and the values will be just like this. Okay, now let's have a go at drawing the rectangle. Okay, so this is the first midpoint, right? I'm going to draw the horizontal line and back down. Okay, so this is my second midpoint. Draw the horizontal line, back down. Right, third midpoint, vertical line, back down. Right, so each one of them you see the rectangles. Okay, I'm going to finish the rest. Okay, just like this. Right, the logic of the rectangle rule is that it's the area under the curve, right? But this part is not under the curve. But if you transfer this part into here, right? This part and that part is very similar. So we're going to move this one, fill in here. Right, move this one and fill in the gap. Okay. Right, move this one and fill in this gap and so on. Just like this. Okay, so basically, if you find the width and the height, times it together, find out the area of each one of them, and add them all together. So basically, you'll get approximately area under the curve. Okay, so this is the table that you need to fill out. N is the number of rectangles you have. So it's divided into 6 subintervals. So 1, 2, 3, 4, 5, 6 rectangles. So in here, you need to write 1 to 6, representing 6 rectangles, right? Width was 0.5, 0.5, 0.5, 0.5, and so on. Everything was 0.5 according to my calculation. Yeah. And midpoint, the value, we already find it up. 0.25, 75, 1.25, 1.75, and so on. Like this. And the height, okay, it's in the function you put the midpoint inside because see over here, that's the midpoint, and that's going to be the height for the red rectangle, right? And that's going to be f 0.25, right? So in there you're going to put 0.25, and instead of x, you're going to put 0.25 and get a value for it. Okay, so there you go. I showed you the calculation for the first 3, and that's going to be all the calculation for the height. Where did I get these equation from? Right, it was from the question, the function, this line, fx is e to the power of x, and I just put midpoint in each one and got the values. Right, now I need to find the area of each rectangle, which is width times the height. Yep, so that times that. There you go. I just multiplied width and the height, and I got the area of each. Right, I just need to add all of them, right? Adding all those rectangles, which will give me 18.9 units squared. Okay, so there you go. That's one way of approximately calculating the area under the curve when you cannot integrate a function. Okay, so that's another useful way to estimate it. Right, this was the rectangle rule. So in the next lesson, I'll come back with a different rule, okay, which is going to be trapezium. And hopefully it's going to be more accurate than the rectangle rule. So let's find it out in the next lesson. Okay, so have a go at doing page 214 in your book. Otherwise, I'll see you in the next lesson. Bye-bye.